Hello friends, just guess what this is. You'll be shocked to know that normally, a galaxy looks like this, but this blurry, fire-like structure is also a photo of an individual galaxy. In fact, in this image, all the blurry galaxies you see in these four axes are actually the same galaxy, Sunburst Arc Galaxy. In fact, why is this? Take a look at this too. How many blue galaxies do you see here? 4, right? Well, all 4 of them are a single galaxy, the Einstein Cross. And in this one too, there's just a single galaxy that appears like a ring, Einstein Ring. But wait a minute, why does one galaxy appear in such strange patterns in all 3 cases? Well, quite interestingly, the reason behind this is something we humans have been doing since ancient times. When our ancestors were sitting in a cave one day, they suddenly saw an inverted image of the outside world on the cave wall. At first, they couldn't understand what it was exactly. They rushed outside to check if the world had actually turned upside down. But upon investigating the cave, they realized that this inverted image was being formed due to light coming through a small hole in the cave. But what was the reason behind this? Well, they didn't have an answer back then, but they saw similar things almost every day. Yes, when they went hunting at night, the twinkling eyes of animals looked just like the glowing light they saw through that tiny hole in their dark cave. This thought evolved over time, and by the time of the ancient Greeks, people started believing that a kind of fire burns inside our eyes, and that fire emits light outward. We are explaining, right? But it was true. About 450 BCE, the Greek philosopher Empedocles had this logic about human vision, that the Greek goddess Aphrodite, while creating humans, lit a flame, like the cotton wick used in a lamp, in their eyes. And when that burning flame's light falls on objects, we can see them. Well, as you can see, the old theory of light is light years away from the modern light theory. But then comes a person who solved this puzzle even back then. The only thing was, that person was a mad prisoner. About 1,000 years ago, in 996 CE, when the Islamic leader Caliph Al-Aziz died, an 11-year-old boy, al-Hakim, was made the next caliph in Cairo, Egypt. Now, al-Hakim was so cruel by nature that he once had all the dogs in his kingdom killed just because their barking annoyed him. His only passion was science. In fact, because of this, he employed many scientists from ancient Persia to work for him. One of them was Ibn al-Haytham, also known as Alhazen, today known as the father of modern optics. Now, let's return to our video. As we saw, al-Hakim employed many scientists, and one of them was Ibn al-Haytham, or Alhazen, the father of modern optics. The thing is, Alhazen once proposed to al-Hakim that he could build a dam-like structure to regulate the flow of Egypt's Nile River. But when he arrived at the site with his team, he realized that the Nile's flow was too strong, and regulating it would be equivalent to putting his life at risk. But how could he tell this to al-Hakim? He would get furious, and that would mean death. So, Alhazen cleverly told al-Hakim the truth about his failure, but also spread a rumor in society that he was mentally insane. Now, let's say a weird thing happened. Everyone believed that he was mentally unstable, including al-Hakim. So, al-Hakim spared his life, but imprisoned him in his own house. Believe it or not, it was because of a decision made by a king 1,000 years ago that the entire world of lensing was established. Because while sitting at home, Alhazen observed something very strange in the sky. He noticed that during a solar eclipse, when the sun was covered by the moon, the entire Earth would, quite weirdly, become dark. This phenomenon sparked an idea in his mind for the first time. Perhaps the source of light is always outside our eyes, not inside them, as people used to believe, thinking the light source was inside animals' eyes. To research this new discovery further, he conducted an experiment. He lit a lantern at home and placed various objects in front of it, closely observing the shadows they cast. He noticed that whenever he placed an object in front of the lantern, its shadow formed behind it. But if the object was on the right of the lantern, the shadow formed on the left, and if it was behind, the shadow formed in front. And that was it. Alhazen became the first person to tell us that light always travels in a straight line, unless, of course, a magnifying lens, a glass of water, a mirror, or a massive galaxy comes in the way. But friends, wait a minute. You might be thinking, Gaurav Bhai, you've told us this whole big story, but how does it justify our sunburst arc? Well, hold on. This one experiment will consolidate everything in your mind. On May 29th, 1919, a total solar eclipse was about to happen, during which the moon would completely cover the sun for 5 minutes, allowing stars to be visible even during the day. So, what happened? Sir Arthur Eddington, to capture those precious 5 minutes, took a boat and a small team to Principe Island off the African west coast and sent his colleague Frank Dyson and his team to Sobral, Brazil. The result? When both teams recorded the positions of the stars visible near the sun from their respective locations, they saw that those stars weren't as close to the sun as they should have been. This meant Einstein's 1915 general theory of relativity was absolutely correct, and massive objects in the universe actually bend light, magnifying its source. When this light-bending phenomenon occurs in the context of space due to a massive celestial object, we call it gravitational lensing. Now, let's zoom out the screen and create a few more curved light rays, and you'll get a clear picture. Now tell me, if this massive object weren't in the middle, would the light traveling in these other directions ever reach us, apart from the direct light? Obviously not. But now it is reaching us. So, if our eyes, as usual, start back tracing these curved lines as straight lines, what will they see? Yes, countless copies of the same galaxy. There are variations in this too. For example, in the case of the Einstein Ring, the source galaxy, the massive object in the middle, and does need to be in a perfect straight line. Only then does an equal amount of light from all directions, up, down, left, right, bend and reach us. If there's even a slight misalignment, you get our sunburst arc. And if only the light from 4 opposite directions manages to bend, you get an Einstein Cross.
Huh?
Luckily, today we don't need to sit and decode these ourselves. We have technologies that can correct even a blurry, C-shaped image like the sunburst arc and show us its real image. In fact, this is why we know today that the Sunburst Arc Galaxy is 11 billion light-years away from us and appears arc-shaped due to a galaxy cluster 4.6 billion light-years away. Yes, I know. You're probably thinking that if the universe's natural magnifying glass is so powerful, and even the sun can exhibit gravitational lensing, then why don't our scientists use it to study distant galaxies? Well guys, think about it. A magnifying glass doesn't zoom in on objects from just any distance. You have to hold it at a certain distance from the book, called the focal distance. Now, listen carefully. In the case of the sun, this focal distance is 14 times farther than the distance from the sun to Pluto. That means we'd have to send a telescope that far to use the sun as a powerful magnifying glass. For comparison, the farthest man-made object to date, Voyager 1, after traveling continuously for 45 years, has only covered 4 times the Sun-Pluto distance. So, it's much better to use objects already far away for gravitational lensing. Anyway, what's your opinion on this? Share it with me in the comment section below. See you next time, friends. Till then, as always, stay curious, keep learning, and keep growing.